Hi, everyone. I hope you all can hear me. Thank you so much for joining us tonight. I hope you're all doing well. This workshop today is going to be a hands-on introduction into data science using Python. So you'll be learning about what data science is, what it's used for, and also get a feel for the day-to-day tasks of a data scientist. The instructor that we have with us today, his name is Vinny. So he'll be guiding you through an interactive workshop where you'll get the opportunity to also code along with him and also learn the basics of Python to work with data. If you have not yet, please just make sure that you have Anaconda installed or that you have a Google account so that you can work with Google Colab so that you can participate in our workshop later. No experience is required to attend. I do want to quickly just talk about who we are, and then I will pass it on to Vinny, who will be going through the workshop itself. So it shouldn't take too long. So to quickly introduce ourselves, we are WeCloudData. So essentially, we help our students make the transition into a career in data. So we are a data and AI training company based in Canada. We provide bootcamp training that can help you further your understanding with data science, business intelligence, data engineering, and AI. And the curriculums that we have are based off of the required skills in the field and market demand. So for example, in data science, we teach popular tools like Python, which you'll see today, and also like tools within big data. So our instructor, Vinny, he will be talking about data science in general and also pandas. So I hope that you guys will all be able to learn a lot from him and ask him lots of questions. I can go a bit more in depth into this later, but I just want to briefly go through this so you have an idea. We also have like a couple of other paths which we provide support. So with our consulting company and also career mentorship. I'll talk about this at the end, but just so you have an idea of what we do. And then I also wanted to mention we do have a couple more upcoming events. So if you're interested after this one in learning more, like for example, in machine learning, Vinny is also holding a workshop next week. So I just have like the quick descriptions, which I will share later. We also have like an event talking about the data science best practices and then also an introduction into big data. So those are in the next few weeks. And then we do also have our data science bootcamp, which is kind of like a preview of what you're doing today. The bootcamp starts in May 24th for our full-time and then June 15 for our part-time. Without further ado, I will let Vinny get started with the workshop, but I will stick around and be able to answer more questions at the end of our session. Are you ready, Vinny?
Good to go.
Okay, great. I will let you share.
Thanks for the introduction. Hi, everyone. My name is Vinny. Let me share my screen. I'm an instructor here at WeCloudData, like Sonia mentioned. And today I want to show you what being a data scientist is actually like. So I'm going to give you a feel for the day-to-day tasks of a data scientist, as well as teach you a little bit more about what it is. And so I'm going to teach this as if it's a real lecture. So to give you a feel for what our actual classes are like, everything's going to be very hands-on and very practical. And so before we get started, before we get started, I have some questions for you guys. Is anyone here not from Toronto? If you're not from Toronto, can you type in the chat where you're from? I'm just curious. Oh, everywhere. This is awesome. Cool. So the reason I was curious is because I just went outside and it's really nice outside, which is surprising for Toronto because it's been really crappy weather lately. And so thank you for attending today and not being outside enjoying the nice weather. So before we get started, I do want to make sure that we're all on the same page. So we have the materials set up. A lot of Vancouvers, nice. So what I want to do is I'm going to send you a link in the chat. It leads to a Dropbox page. So it'll lead to this page here. And all you have to do is just download this file. Once you have that file downloaded, just move it somewhere where you can easily access it. So mine went into my downloads folder, and I'm just going to drag it onto my desktop. But feel free to put it wherever you want. And so for those of you on Anaconda, if you have Anaconda, you should be able to open something called Anaconda Navigator. I'll go over these instructions again in like half an hour or so after I do the intro, in case you missed it. But for those of you who are here now, hopefully you can follow along. So again, download the file, put it somewhere accessible. And then if you have Anaconda, you can open Anaconda Navigator and then click on Jupyter Notebook, which should open something like this. And then just navigate to wherever you have your file. So again, because mine is on my desktop, I just navigate to the desktop. The file should be here. And if you click on it, it should look something like this. Sorry, give me 1 second. I'm just going to type this out really quick so you guys have it all in one place. Okay, so those are the instructions if you have Anaconda Navigator, if you have Anaconda. If you don't have Anaconda, we're going to use a tool called Google Colab instead. So the first part is the same, download the file. But instead of opening up Anaconda Navigator, what you're going to do is you're going to go to this link instead. So I'll send you the link in the chat. Which should open something like this. You might have another box that looks like this. You can just hit cancel here. Yeah, once you have this, you should be able to click on File and then Upload Notebook. Perfect. Yeah, so Colab will work regardless of if you have Python installed. It's just an online tool that we're going to use, but you do require a Gmail account. So it's a Google tool. So you will require a Gmail account. If you have one, then it should automatically log in. And then yeah, once you have that, it should just be File, Upload Notebook, and then find that file that I just talked about. So mine is here. I'm just going to click on it and click Open. Put that in the chat again for you. So I'll give you a second to get that set up. If you have any problems, please do let me know. You don't need to follow along, but it's really boring if you don't. So hopefully you can get this set up and you can code along with me. Any questions or problems so far? Okay, so hopefully you have that. I'll go through this notebook in maybe half an hour or so. Before we do that, though, I'm just going to give you an introduction to what data science is. So I'm just going to switch screens really quickly. Give me 1 second. So if you came in late or you missed a portion of that instruction, don't worry too much about it. I'll go over it again after I do this introduction. So for this class, just like any of our other classes at WeCloudData, I want it to be as interactive as possible. So feel free to just turn on your mic if you have a question. So I'm going to ask a lot of questions, and you guys can help me answer them. If you have any questions of your own, feel free to turn off your mic, say hi, and I'll be happy to answer those questions. So speaking of which, can anyone tell me what is data science? Are we shy, or are we here because we don't know and we're trying to find out? Yes, Randy knows. It's surprisingly a hard question. It is. It's not an easy question to answer. And actually, I don't have a concrete answer for you. So I'm hoping you guys can help me.
Is it like to extract meaningful insights from a data?
For sure. That's definitely going to be a huge aspect of it, which is, extracting meaningful information from your data to hopefully maybe solve some kind of business problem. Yeah. Anyone else want to add to that?
It's the study and analysis of data.
Yeah, for sure. So that's one of the main portions of the word, right? Data. So we're going to be studying that data, analyzing that data, definitely. Anything else? Conjunction of CS and statistics. Yeah, I like that answer. So because data science is a multidisciplinary field, it actually involves quite a few things. And two of those things, the pillars of data science, are going to be computer science and statistics. Daniel says we need to make predictive models to solve business problems. Yeah, perfect. So another big portion of data science is something called machine learning, where we're building predictive models. And so we're not going to spend as much time on the machine learning side. If you do want more information of that, we do have a follow-up session next week. I'll talk more about that later, where we're going to cover machine learning in depth. Science implies generating and testing hypotheses. Yeah, definitely. So it's not just the data part, but it's the science part too. So we have to know how to set up hypotheses, experiments, and see if we can solve those. Extracting knowledge and insight from data. Yeah, so I think we've got the general idea of what it looks like. To make it a little more concrete, I'm going to draw this Venn diagram. It's going to have three portions, and data science is going to live here right in the middle, the intersection of these three. Can anyone tell me what these three are?
Venn diagram.
What am I going to fill the Venn diagram with? Yeah. I think someone mentioned it earlier, right? So statistics and computer science. It's two of the big portions of this Venn diagram. AI, stats, machine learning, AI, math, computation. Yeah, so a lot of these are very similar. I'm going to lump all of those into the stats and math part, the AI part, the machine learning part. Although I guess they technically include both of these. But there's one other section.
Domain knowledge.
Yeah, that's the one that I forgot when I first started learning data science. I actually come from a web development background. And so I'm really good with the computer science side. I'm not too bad at the math side, but this portion is actually a very important part that people tend to forget. It's not just using computers and math, but it's also understanding things, because we're trying to solve business problems. And so if we can't use the computer and math to do that, then it's pretty much useless. So I'm actually going to call this section domain knowledge. So that means understanding what the business problem you're trying to solve actually is, and then using your knowledge and your tools from data science to solve them. And so it's going to involve a lot of computer science. We're going to be using the computer to crunch our numbers for us, using machine learning algorithms that run on computers. It's a lot of stats and math. That's the data part. Because we're dealing with data, we need to understand that data using statistical tools and mathematics. And if we're building any kind of machine learning or predictive models, those are also going to involve a lot of statistics and math. And then, yeah, the domain knowledge part. So for example, if you're trying to use data science to work on, say, in the medical field, I want to use data science to predict cancer using MRI scans or something like that. You definitely need to understand a lot about the medical field, what attributes actually affect a tumor, what those readings actually mean, what the data itself looks like. And so you'll have to understand the domain part of that as well. If you're working in retail, you have to understand what kind of attributes and statistics influence whether a customer is going to purchase your product or not purchase your product. And so that's where the domain knowledge part comes in. Does that make sense? Any questions, or does anyone want to add anything? Absolutely. I like the confidence. Great. Okay, so as a data scientist, what are you actually doing? So I'm going to walk you through a typical data science workflow. Not every project is going to look like this. Not every data scientist in every company is going to work like this. But in general, they'll probably include each of these steps. So it could get a lot more complicated, but this will be the basics. This will be the foundation for what you're trying to do. So does anyone know by any chance? What's the first step? The company hires you as a data scientist. They put you on a project. What's the first thing you're going to be doing?
Problem statement.
Yeah, that's great. Most people forget that. Most people think that the first step is collecting the data, digging into the data, something like that. But actually, even before that can happen, we need to define the problem statements. I want to call this the objective, or you can think about it as the motivation. But essentially what that means is we need to define what we're actually trying to do. Because from the business perspective, if what you do doesn't align with what the business problem actually is, then your project might be completely useless. And so the very first step is to make sure that what you're doing actually aligns with what the business is trying to accomplish. And so for this workshop today, we're going to be working with a data set that you might have seen before. If you've ever done like an introduction to data science class or a lecture or an online course or read a blog post, they usually use this data set. It's the Titanic data set. So every row in this data set represents a passenger in the Titanic. And you have information about that passenger, like are they male or female? How much did they pay for their ticket? Which port they went from, were they in first class, second class, third class, things like that. And then we're going to try to build a model that predicts, based on those attributes, did this person survive? Yes or no? And so we can use data science and machine learning to actually build a predictive model that will be able to answer this question for us. And so that's the idea. That's the first step. We need to define the problem and figure out how to solve it. Does that make sense? Any questions so far? Okay, cool. So after we figure that out, after we know what we're doing, we're going to start dealing with the data. So that's the data part of data science. And does anyone know what happens first? So this is going to involve a few steps. Does anyone know what the first step is? ETL. Fancy. What does ETL stand for? Oh, sorry. Yeah, go ahead, Adnan.
Acquisition of the data?
Yeah, so that's actually the first E in that ETL. It's the extraction of the data. So I'm going to call it collecting the data. So the very first step is retrieving that data. Let's talk a little more about this because it's not as simple as it looks. Does anyone know, where does data come from? Everywhere. Anything can be measured. Yes, the data gods. Yes, all of these are absolutely true. A little more Down to earth though. As a data scientist, where are we pulling the data from? The universe.
Database.
Database, yeah, that's probably going to be the main area that we're going to pull data from. And from a business perspective, does anyone know what kind of databases people are using?
Heard
SQL
about-
databases mostly.
Yeah, it's going to be a lot of SQL databases.
Oh, okay. I've heard about no SQL.
For
I
sure.
mean, yeah.
That's definitely going to be a big portion of it as well. NoSQL. I'm going to keep the focus on SQL just because most of the time it is going to come from a SQL database, but you're absolutely right. There are other databases that are kind of SQL adjacent, but not quite SQL.
Okay.
And so you definitely will pull data from there as well. You're going to pull data from multiple places. I'm going to talk about lots of different places it can come from. But SQL in particular is going to be a very big one because most companies have their data stored in some kind of relational database, some kind of SQL database. And so quick question for you guys. How many of you know SQL? Just out of curiosity. If you know SQL, maybe type a 1 into the chat. 0.5. Yes, that's the scaling system I'm using. Spoken like a true data scientist. Floating point number. Okay, quite a few of you. Yeah, so you'll be familiar with this. It's a way to query these databases to pull out information, to access information. And so yeah, that's where it's going to come from a lot of the time. And that's why this is so important. As a data scientist, I would say the two most important skills are going to be SQL. Maybe three. I'll do three. Some kind of programming language. So in our course, we learn Python. But in other courses, maybe you learn something like R, or maybe even Java or something like that, some other programming language. We're going to stick to Python, and I'll explain why a little bit later. And then the other big portion is going to be machine learning. So again, these are probably a little outside the scope of our workshop today. But if you are interested in becoming a data scientist, you'll definitely have to know these things. Good, does that make sense so far? Any questions?
Hi, I just have a question.
Yeah, sure.
You put machine learning as a separate from SQL and Python. Does it involve a different programming language, or is it mainly like creating models, or more on math than programming?
Yeah.
I'm totally newbie, so just one.
No worries. That's a great question. Yeah, I put machine learning here as its own topic, but you're right. It does use those exact same tools. So these are tools. SQL and Python are tools. Machine learning is like the theoretical knowledge that you need to use those tools. And so everything I'm going to explain to you now in this workflow can be done directly in Python. So even the SQL portion can be done in Python. You can actually use Python to access these SQL databases and pull the data out. But yeah, great question. Good. Any other questions? Okay, cool. So let's continue. Where else can data come from?
Research.
Hello.
Research. Yeah, for sure. Sorry, give me 1 second. That research, what kind of research? Like,
I just don't research.
some kind of research.
I think some data comes from, sorry, am I interrupt you? Sorry.
Oh, go ahead.
Okay, sorry. Some data can we crawl it from websites or maybe social media, and so we can consider it as unstructured data. So I think another source of data could be social media and text and videos, graphs, and these kinds of things.
Perfect. Yeah, that's great. All those things, yeah, I would lump them under the same category, unstructured data. And usually if you're pulling this stuff from websites, so for example, if I want to analyze, say, my company's public relations. How well do my customers actually like the product that I put out? I like my company itself. Maybe I want to analyze Twitter. So I can pull out information. Let's say I'm Walmart or something. I can pull out all the tweets about Walmart, and I can measure their sentiment. Are these tweets happy with their services at Walmart, or are they angry about their services at Walmart? And then I can measure that. And then I can measure that trend over time. So maybe I can see this month, it looks like this, 70% of people are happy. Next month, only 40% of people are happy. So maybe that's going to be a problem and we should do something about that. So yeah, we can definitely pull that data out. And we usually call these web APIs. That's the technical name, application programming interface. And so a lot of different websites and online data will have web APIs, or you can scrape the data where you actually pull them out from the websites themselves. So again, that's a much bigger topic. But yeah, you can definitely get it from different websites and social media and things like that. For sure, yeah. So a lot of these companies are going to collect things like your cookie information and stuff like that. And then you might be able to access that data through, like I mentioned, something called a web API. Yeah, a web API is basically like a web server. So that's what they're pulling it from. Or that's where you as a data scientist are going to be pulling it from. Cool. Anywhere else? Surveys is a good one. Sometimes you might actually collect the data yourself. So maybe you send out, one of those, how satisfied are you with your current, whatever, phone service? And so maybe we're manually collecting that data yourself as a company, and maybe you put them into surveys, and maybe you take those survey information and you load them into your database. IoT devices is a cool one. Yeah, so as technology gets more and more advanced, we're starting to be able to measure pretty much anything. So your answers about where data comes from, which is everywhere, is kind of true. You can get information from everywhere. So if you don't know, this stands for the Internet of Things, which is any kind of device that's going to collect real-time data. So like your Fitbits and your smartwatches, you can think about those as like IoT devices, or like if I want to measure traffic patterns in a city, I can set up like detectors on streets and have those measure the flow of cars and things like that. So yeah, you can definitely get it from there as well. Scientific research, experiments, results, health. Yep, definitely. Metadata, yeah, it's a lot of places. Okay, so I want to cut this discussion short because you guys are absolutely right. It can come from an infinite number of places. The last one I want to mention is Excel spreadsheets. As simple as they are, a lot of companies, if they're not super big, maybe this is enough. I don't need some kind of large database to hold all my information. Maybe I just collect all my information inside of some spreadsheets. And so you just kind of email spreadsheets back and forth around. And so yeah, as a data scientist, you're going to need to know how to access all these different kinds of information. And then using Python, manipulate that data, analyze that data, and maybe build machine learning models from it. So that's going to be the very first step. And the programming that we're going to use, called Python, is going to be able to do all of that. So you don't have to learn, 5 different languages to do this. Python will be enough to do all of that. Good, does that make sense? Any questions? Great. Okay, so we've talked about lots of different places where we can collect data. We have the data now. Does anyone know what happens next? Normalization. That's a cool word. Cool. I'll add that in a little further down, okay? But yeah, I think some of you got it. Cleaning the data is actually going to be a very important first step that you're going to need to do. Does anyone know why? Why do we have to clean data? Isn't the data already, what does it even mean to have messy data? Yeah, raw data is going to be very messy. What does it mean for it to be messy? Yeah, you might have things like duplicate records. So maybe the way it was collected, you collected it multiple times. So I don't want, say, if I'm collecting the average age of my customers, if I have the same customer in there multiple times, I don't want that to drag down or up the average age. Some data, yeah, you might just not need it. It might be information that just isn't relevant. What kind of hats does this person like? Probably isn't going to tell me anything about whether or not they have cancer. Missing data, yeah, missing data is going to be a big one. So sometimes if you're collecting, if like your customers are filling out a form and you need to collect that data, sometimes they won't fill in one of the boxes. And so you're going to have to clean that up. Data can come in different formats, it's disorganized. Yeah, I like that phrase, rubbish in, rubbish out. I use that all the time. I use it as garbage in, garbage out. So if I'm feeding in bad data to my machine learning models later, they're going to learn the bad patterns and then not be able to make good predictions. And so yeah, all those things are going to be true, which is why we have to clean the data first. And so this is where you actually spend a large portion of your time in data science, which is just wrangling that data. Cool, okay, so we've loaded that data in, we've cleaned it up, so now it's actually usable. What happens next? Does anyone know? Explore the data, yeah, that's a great one. So I'm gonna give you the technical name for this. It's called EDA. Does anyone know what that stands for? Yeah, somebody has that acronym. We like our acronyms here. Do you know what it stands for? Yes, exploratory data analysis, perfect. Which is exactly what it sounds like. You're going to explore the data and do some kind of preliminary analysis on that data. So I want to find out things like, what's the frequency of my customers? How often do they actually shop at my store? I can build lots of visualizations, right? I can make plots and charts to understand the data. And so that's what this is. It's building out these charts, data visualizations, calculating things like summary statistics. What's the average age of the customers on the Titanic or something like that. So this is where the statistics side comes in. Understanding statistics will help you understand the data better, help you build plots and charts to help you understand that data and to help you communicate that data to somebody else later, right? So part of your job as a data scientist isn't just, dealing with the data in like a dark basement or something like that. You have to be able to communicate your results to somebody. So a large portion of being a data scientist is actually, it's this part here actually, it's the domain, I included in the domain knowledge part. It's communications. Or maybe, yeah, maybe I'll just call it communication. Actually, I like to think about it as you're kind of like a storyteller. You need to be able to use this data to build some kind of narrative. So for example, if it's this Twitter example that I gave you earlier, if I'm analyzing the sentiment of tweets over time, then I can communicate this as a story, right? The beginning of the year, everybody was happy with our services, but during the summer months, people were not satisfied with our services. And then come fall and winter, they were satisfied again. So maybe during those summer months, what did we do differently? Can we change the way we're actually performing our business, or maybe give out different products that are better during summer or something like that? So all of this we can figure out through exploratory data analysis. Does that make sense? Any questions there? Okay, cool. So the last one I want to mention, actually, I'll mention it out here, which is if we are going to use some kind of machine learning. So again, the focus of this workshop today isn't on the machine learning aspect. And so if you want to learn more about machine learning, I will be continuing this workshop next week, next Thursday, I believe, where we'll actually continue from the notebook from this lecture and cover more of the machine learning side. But just to briefly give you an idea of what that is, can anyone tell me actually, what is machine learning?
It's creating models that can predict data.
Predict something, right? For sure. We're going to be getting models that are going to be able to make some kind of prediction. So that's going to be a large aspect of it. It's not the only aspect of it. You can actually build non-predictive models as well. It's basically glorified statistical analysis, which it really is. We just got better at using computers to do the statistical analysis for us. But yeah, you'll see a lot of overlap between traditional statistics and machine learning. It's just fancier programming for the same stuff. Teaching a machine to learn like a human. Yeah, I really like that definition of it. Guessing a function that is not known for us. Yeah, so if you think about a statistical model as exactly that, a mathematical function, that's essentially what you're doing. An algorithm that allows us to predict non-parametric variables. Yeah, so that could be one aspect of it, non-parametric. Measuring some kind of relationship. Yep, for sure. So I'll give you an example to illustrate this. So again, there's lots of different types of machine learning. But let's say this is you. You have a very large credit card. It's the size of your head. And you go to the store and you make a purchase. Let's say you go to Walmart or something and you make a purchase. Does anyone know what happens next?
You enter your payment details.
Sure. You enter your payment details. Yeah. And then where does that information actually get sent to?
Payment processors.
Yeah. So it goes somewhere, right? Where it has to process that payment. And something else has to happen too. Does anyone know what I'm getting at? So this particular machine learning example I want to give you is called fraud detection. Does anyone know what fraud detection is? Yes. Can anyone tell me what fraud detection is? Yeah, so like credit card fraud, something like that, right? So basically, if you make a purchase and your credit card company thinks it's fraudulent, they'll probably give you a call. This has probably happened to you before. They give you a call to say, did you actually make this purchase on this date at this time? And if you did, then great. Then they'll let the transaction go through. If not, then maybe it got canceled, right? Because they thought it was fraudulent. So does anyone know how they make that decision? How do they decide if your transaction is actually fraudulent or a real transaction?
Compare our current transaction to previous behaviors and history of transaction based on location and other parameters.
Perfect. Yeah, that's great. So analyzing that data, yeah. So a large portion of that data is going to be transactional data. So I'm going to call that TXN for transaction. And so that involves things like, where was this transaction made? At what time was this transaction made? How much did that purchase cost? How many of those items did they buy? Things like that. So all of that I want to call transactional information. But also we have customer information. So I'm going to call that CXN for customer. And that involves things like information about the customer themselves. So how old are they? How long have they had an account? How long have they had, say, this credit card? Things like that. So the combination of these two pieces of information will allow this. So it'll be a server, right? A server is just a computer without a monitor. So something that crunches numbers for us. And so on the server, it'll extract this information, transaction and customer information, and then it's going to make a decision. Based on that information, it's going to decide, is this transaction fraud? Yes or no? If it is fraud, then they're going to stop that transaction from going through. If it's not fraud, then great, allow that transaction to go through. And so this server here, the rules that define whether or not a transaction is fraudulent or not, Does anyone know where those rules come from?
They get programmed.
Yeah, they definitely get programmed in there. Who does the programming? So what I'm getting at is the traditional way this is done. So without machine learning, so that's no machine learning, is to use a bunch of fraud experts. So people that, their expertise is actually detecting fraud. And so they understand what kind of patterns will contribute towards fraudulent transactions. So for example, if I make a purchase here in Toronto today at this time, and then 5 minutes later, I make a purchase in Paris, France, that probably will be a fraudulent transaction. If I completely max out my credit card buying a bunch of random things throughout the day, that's probably a fraudulent transaction. And so these fraud experts will work with software engineers to basically encode these rules directly into the server. And so they'll encode these rules into the server. And so given new transactional data and customer data, we'll look at the rules. And if it passes those rules, great, it's not fraud, allow the transaction to go through. If it doesn't pass those rules, then it is fraudulent, stop the transaction from going through, and then call the customer to see if they actually made that purchase. Does that make sense? Actually, I want to put this down here so it's a little easier to see.
I just have a question.
Yeah, sure.
With the traditional method you were talking about without machine learning, does that mean previously it would take, it's not real time, like it would take really long time before transaction gets approved or something?
That's a great question.
I'm
Yeah,
just
so
trying to understand.
the rules that they're going to embed into the server have to happen quickly. Yeah, because we can't just, you as a customer don't want the customer experience of having to wait like 5 minutes every time you make a purchase, right? And so the rules that they do encode will happen very quickly. So if you know anything about programming, it's going to be like a bunch of if-else statements. If this and this and this and not this, then do this.
Oh,
So,
okay, okay.
yeah, all that information will get passed in, and then it'll run through that kind of structure of if-else statements, and then lead to a simple yes or no answer. So it does have to happen real time. You're absolutely right.
Okay, so it's real time as well. Okay, so I'm just curious, like how machine learning actually improved this process. So.
Right, for sure. So yeah, in that sense, it's the same. They both do happen in real time. There's not like an army of people in a factory somewhere manually going through every transaction as it comes in. That would be impossible. It is still going to be computers, but it does use a slightly different approach. So let's talk about that slightly different approach. So with machine learning, we have this idea of training data. So you can just think about this as like historical data, so old data that you have access to. And maybe it looks something like this. So we talked about how there's transaction information and customer information. So maybe the transaction information says something like location. Where was that transaction made? Price. How much did they spend on that transaction? Quantity. How many of those items did they purchase? So all this I'm going to call my transaction information. And then I'm going to have things like customer information. So like the person's age, email, address, things like that. So you can have a whole bunch of that. And I'll call that customer information. So you can think about this like a table. There's multiple rows in the table. Each row is one transaction. And so you have information about the transaction itself and information about the customer. And then you have, very importantly, we call it a label in machine learning, which is basically, was that transaction fraudulent or not fraudulent? So for every one of these transactions, we have a label. So again, you have to collect this information ahead of time. This is historical data. So maybe as a company, you've been running for 2 years and you've been collecting this information for 2 years. You have people that are going to go in and label these transactions as fraudulent or not fraudulent. You'll know by that time. And what machine learning is going to do is, rather than us hard coding the rules, so previously we would have to have fraud experts hard code those rules into the computer. With machine learning, we don't do any of that. We just allow the machine to figure it out. So we feed all of this information into an algorithm, so machine learning algorithm, and it's going to learn based on the location, price, quantity, age, email, etc., if that transaction is fraudulent. So it'll learn how to go from the pattern to the label based on the next person's whatever location, price, quantity, age, email. The machine will learn that this is not fraudulent. And so you'll give it hundreds and thousands of examples of this, millions of examples sometimes. And then the machine will learn the pattern between the two. And that's what your machine learning model is. It's basically going to model these attributes along with their label. And then when you give it new data, so as new data comes in, since your model has already seen examples of this, it'll be able to make the decision. So you'll actually train your model, and then you'll put that model onto the server. And then the model, the machine learning model, is going to make this decision for us instead. So we're completely replacing this portion with the machine learning portion instead. So that's the difference. It's not in the speed or the calculations or anything like that. It can be. But the bigger part is we're actually using data that the machine is going to learn from, rather than leveraging the information inside these fraud experts' head. Does that make sense? Any questions? How accurate would it? Yeah, so if you're doing this right, you can get very, very good accuracy. And so part of your job as the data scientist, sorry, I gotta scroll up a little. A big portion of your job is this portion here. So we have all this data with the labels. We're gonna clean it up, explore it, and then feed them into this machine learning model, train those machine learning models. And you're gonna have to do a bunch of things. You're gonna have to, well, train the model. And you're gonna have to evaluate how well that model actually performs. So you'll have like some kind of test data set that your model hasn't seen before. Maybe, I don't know, 10,000 examples of transactions that your model hasn't seen before. So basically, a data set like this, but without the label. So you won't have the label, and you're going to have the model predict on this information. And then it's going to generate its own labels, its own predictions. Is this fraud, yes or no? And then you'll also have the true labels, and you can compare. So how many did the model actually get correct? And so you can use something like that, your model evaluation technique, to gauge how well the model actually performs. And ideally, you'll have some kind of threshold on how accurate it needs to be. So if, for example, I calculate that for my company not to lose money, I need the model to be at least 90% accurate, then that's going to be how well you're going to train the models to perform. And yeah, so for certain tasks and use cases of machine learning, humans are better. And for other tasks, the machine is actually better. So if you've, I don't know, read up on any kind of machine learning state-of-the-art research and stuff, things like image recognition, some types of like radiology, MRI scans for tumors and stuff, the machine is actually almost as good, if not better, than humans at this point. And so it really depends on the topic and the task at hand. But yeah, in general, it's going to be as accurate, if not more accurate, and it's going to be more efficient, because now I just have the computer doing it rather than hiring, you know, a team of fraud experts that's going to cost me $100,000 a year or something like that. No problem. Good. Any other questions?
I just wanted, like, just to confirm, because I recently applied for a credit card, and they use like they require you to and it's real time. They require you to take a photo of your ID, and then the next step would be to take a selfie, and then they would determine if the photo on your ID matches your selfie photo.
Oh, interesting.
Is that technology using kind of like machine learning as well? Like image?
I would imagine it does use machine learning. So in that sense, rather than going from transactions and customer information to a label of fraud, yes or no, they're probably using things like an image, 2 images actually, and then measuring whether those images are actually, matching or not, yes or no. And so it's structured the same, but the task is going to be a lot different. Yeah, so the data that you're working with is a lot different. It's going to be the pixel values in the pictures. And then your label is going to be, does this match yes or no, rather than fraud yes or no. But yeah, I would imagine that would be done using machine learning. Machine learning is really good at doing things like images, text, audio, that kind of stuff. It's a lot better than humans at this point.
Oh, okay. So plus it takes time rather than someone reading your file and comparing it.
For sure, that's really expensive, right? Human labor is expensive unless you outsource to a third world country. But you don't want to do that. So computers are better.
Thank you.
No problem. Good. Any other questions? Cool. So yeah, once you have that model built, you've trained the model, it gives you accurate predictions, and then you want to use it in real life, right? So we call that process deployment. And essentially what this means is you're going to put the model onto some kind of server so that it can make predictions in real time. So in our example here with the fraud detection, after we're satisfied with our model, it's been trained on millions of examples. It gives us very good accuracy. We are very confident that it works. We take that model, put it onto the server so that it can make real predictions in real time. So now our customers can actually make the transactions. That information gets sent to our machine learning model instead. The model will crunch the numbers, give a prediction, fraud yes or no, and that will allow us to stop the transaction or allow the transaction to go through. So that process of taking this model after it's been trained and putting it onto the server, that's called deployment. So yeah, that is its own task. For example, here, I don't want the customer to have to wait for 5 minutes as the transaction is going through, right? No business is going to sign up for my credit card machine if it takes 5 minutes every time they need to make a transaction. It would slow down their sales by a lot. And so part of this might be to increase the speed of your model. Maybe your model is too slow and I need to actually optimize it so that it can make those predictions faster or something like that. Maybe I have way too much data coming in. If you're like, I don't know, MasterCard or something, you're getting millions of transactions per hour, per day, or something like that. And so I have to be able to crunch those numbers without losing any information or screwing it up in any way. And so, yeah, it might be your job to actually, the deployment step isn't as easy as it looks. Suman wants to know, how do we do that? Well, sign up for our course. It's a very big topic, but essentially your model is just a bunch of math and computer science, right? It's just a bunch of programs for this, do this, if this, do this, and crunching some numbers. And so it really is just a program. And so you're going to take your IPython notebook, convert it to a Python script, and then upload that script to the server. But yeah, that does require a little bit more computer science knowledge, so I'm not going to dig too deep into that. But in Python, it actually isn't that hard. There's a model dot save. And you just take your model and you do dot save and you save it as a file. And you take that file and you put it here, and then you do a model dot load on the server. In a nutshell, that's what you're doing. load on the server, save in your notebook. Good, any other questions? Okay, so all this is kind of like an iterative process. So he wants to know, when are we going to learn pandas? In 5 minutes. Let me get through the start part, and then we're gonna jump into the notebook.
Before you go to the next topic, I just have a question. Since you introduced us to the workflow.
Yeah.
So like just my initial overview. I believe, like, for me, like much of the work or your time will be spent on actually training your model and testing.
Mm-hmm.
And like, I just want to understand, is it as a data scientist or a data engineer, like in your everyday work, or just, I guess I just want to know, like, is it gonna be, do you spend more time or resources in gathering data or training and testing?
Yeah, that's a great question.
Actually make a profit, like if you're a business doing AI for different businesses and you train these models, so like where are your resources mostly spent on? And just trying to understand, like, the.
For sure. Yeah, let's talk about that. So part of the objective stage is trying to figure this stuff out, right? So if you're doing this, maybe you're doing this exact project, the objective stage is going to be something like, we need to quantify how well, so we have the traditional method, and now we want to upgrade to the machine learning way. We think that that's going to be better, it's going to be more efficient and more accurate. So the first thing you're going to have to figure out is, how well does the traditional method currently perform? So you can measure this simply through something like accuracy. So maybe right now it gets something like 80% accuracy. That means 20% of them we're losing money in that 20%. And so your goal as a data scientist is to increase that accuracy, go from 80% to 90% or something like that. So once you've determined that, you'll walk through this workflow. And I do want to mention that it is an iterative process. So these arrows work in both directions. So for example, if I define my objective and I realize after I collect the data, oh wait, this isn't going to be possible. We don't have enough information to do this. The data we have is way too messy. It would take way too long to clean. It's not going to be worth the time, right? So again, you would have to figure out, how much money am I losing? If it's going to cost me more money, then it might not be worth it to even do this, right? So the idea is, is this feasible, first of all? And then, you might have to go back and adjust the objective. So the way we have it currently set up, it's not going to work. We're going to have to go back, readjust the objectives. Same thing here. We build a machine learning model. It doesn't work very well. So maybe we need to go back, collect more data, clean the data. After we deploy the model, maybe it works for a couple of days, but then a month later, it starts to get terrible results. So maybe you need to go back, adjust the model, retrain the model, things like that. And so as a data scientist, you might need to do all of these things. If you're in a small enough company, you might actually have to do all of these things. And I would say, to be a good data scientist, you should at least understand how all of these things work. But the focus will be on, so let's say for certain tasks, the focus might just be here. Maybe the business just has a question that they need to know. Is have our sales gone up or down within the last 3 quarters or something like that? And so for that, you just need to collect data, do some kind of exploratory data analysis, build a dashboard, explain to them that, something like that, right? And that's the end of your project. So you're spending the entire time, well, just on this portion, right?
Okay.
For certain tasks, you actually do have to build a machine learning model. So if it's fraud detection, for example, we do want to replace this traditional method with a machine learning model. And so you'll spend more time here building that machine learning model out. Okay. And then for certain tasks, it might need to be deployed. Sometimes it doesn't have to be deployed. Sometimes I just need to know, I want to build a model to predict, let's say I'm a telecom company like Bell or Rogers. I want to predict when a customer is going to cancel their internet subscription, so I can send them a coupon. In that case, I don't even need to deploy the model. I just need to send a report out to my marketing team to tell them these 100 people are most likely to leave our services. You should send them a coupon. And so it really depends on the task. But I would say if you're comparing, let's say, the modeling portion to the handling data portion, you're spending way more time here. So maybe something like 70% of your time is spent just dealing with the data, because that is the trickiest part. The data is never going to be clean. It's going to be messy, and you're going to have to get really creative in the way that you structure that data and the way that you clean that data up and the way you analyze that data through the exploratory data analysis. So that actually is where you spend most of your time. Maybe 20% of your time is spent on the machine learning side, actually building the models themselves, because the tools that you're going to use kind of do a lot of the work for you. We're not writing algorithms from scratch. We're going to be using libraries that already have these algorithms written for us, and we're just leveraging them as tools.
Okay.
And then maybe you spend 10% of your time on this stage. So like communicating that result to somebody or deploying that or whatever the case may be. Does that make sense?
Okay. Yeah, absolutely. It gives me an insight into how like, you know, how your work as a scientist from day to day. I mean, data scientist. So it's nice to know these things, you know, you'll not be surprised. I signed up for, I want to do a lot of modeling. Why am I just working on data all day? I don't kind of, you know, this you won't be surprised. And yeah, it's good.
For sure. Yeah. So I was disappointed too to find that out. I'm just spending all my time here because I like the programming side. I like this stuff, but there are a lot of like data adjacent jobs. So for example, does anyone know what a data engineer is?
Well, I kind of have an idea. Like it's, I don't know. I just know about like machine learning engineer. Maybe it's similar. Or
it's the ETL stuff. Yeah. So it's kind of like the guy that has to do the plumbing before the data scientist can do his job. So this part here, structuring that data and making sure it goes to the right place, making sure that if there's lots of data, you don't lose any of that data, making sure that the right people have the right access to that data, setting up all that infrastructure on how the data moves from say here to how it's being collected and how it's being distributed to different teams and how they're going to use that data. And so if you're working with like terabytes of data, you definitely need a very good data engineer to figure out how to move that data efficiently without losing any of it. And so I would say that's a little bit more on the data engineering side. And so if you prefer the programming side of things, so again, data science is a multidisciplinary field. So it includes all these aspects. But if you prefer more of this computer science side, maybe data engineering is more for you. If you prefer the stats, math, the analysis side, then maybe you prefer being a data analyst. So a data analyst, on the other hand, spends more of their time focused on this part here. So less so on the machine learning side, less so on the hardcore programming side, and more on just digging into the data, understanding that data, and then communicating those results to somebody. So maybe they're using slightly different tools. Maybe they're not using Python because they don't need the power of Python to do all this fancy stuff. They just need Excel. Or maybe they just need Tableau to build dashboards or something like that. And so, yeah, because data scientist is such a broad job description, I guess, it might involve a lot of these things. It might involve none of these things. Maybe you're just doing this part. So it really depends on the company and the job you're applying for. And so I wouldn't trust like job descriptions that companies send out. This is a data science position. And then you read through the skills and the tools that job actually requires. And it's all SQL. If that's the case, I would put that closer to data analyst rather than data scientist. But again, there's no concrete definition of these things. And so different companies will use different definitions. Scientists get to do the fun part. It really does depend on who you ask. I originally thought this was the most fun part, but I actually started to like this part now. But yeah, it really depends on who you are and what kind of tasks are interesting to you. Good. Any other questions before we dig into the pandas part? I know Zekai is very excited for pandas. Panda's the tool, not the animal. Okay, so let's jump into it. So I'm going to share my screen again. So we might not finish this entire notebook, but we'll go as far as we can. And if there's anything we don't finish, again, I am going to do a part 2 to this workshop next week. I will complete the rest of the stuff there. But before we do all of that, let's take a quick break. So if you have this set up properly and it works, and you're either in a Jupyter notebook or you're in Google Colab, and you can make a new cell and you can type 1 + 1 and then run it. And it gives you 2, then you're good. Feel free to take a break. Or if you're in Jupyter Notebook, same idea, just plus button, make a new cell, do a 1 + 1, and then run it. If you get an output 2, then you're good. So for those of you who are good, let's say we'll take a break until, I'll give you a little extra time. So let's say 7:25. So we'll give it to 7:25. Come back for, that's oh, my math is bad. 14 minutes from now. We'll continue in 14 minutes from now. If you came in late and you're wondering what I'm talking about, so yeah, again, if you're good, just feel free to take a break. For everybody else, if you came in late, I'll walk you through the process one more time. Yeah, I'll share the notebook with you. So you can find the notebook at this Dropbox link. I sent it to you in the Zoom chat. And it'll lead you to a Dropbox website where you can just put download to download the notebook. Once you have the notebook downloaded, you can leave it wherever it is. Mine goes to this downloads folder, or you can move it. I would suggest moving it just so it's not confusing. I took mine and I moved it to my desktop. So it's here now. So once you download the file from Dropbox, move it to somewhere convenient for you. I put mine on my desktop. If you have Anaconda installed, I'm pretty sure you know what you're doing if you have Anaconda installed. If you have Anaconda installed, just open up Jupyter Notebook, navigate to where that file is, and click on it. And it should open a Jupyter Notebook like this. And again, just make a new cell, click the plus button, type in 1 + 1, click run, make sure that that works. If you don't have Anaconda, you're going to be using something called Google Colab. You can just search for this directly. But I'll send you the link in the chat. So if you go to Colab, it'll open up this little pop-up. You can just cancel. Click on File, Upload Notebook, choose File, find that file on your computer, click on it, and then just open. I'm just going to type this out in the chat one more time so you have it all in one place. Okay, so it's in the chat. So once you open it, it should just look like this. And again, just make a new cell. You can just do plus code here. This will be a code cell, and you can type in 1 + 1, and then click the little play button. Good. Does that make sense? Any problems with this? Okay, so hopefully you have that. If you do, again, feel free to take a break. If you have any troubles, let me know and I'll help you fix it before we come back and continue. We need some storage. Interesting. Is it giving you an error message or something like that? You can have some of my storage. I don't think I can send you storage. I don't know how that works. I think it uses your Google Drive to store the file temporarily while you're using it. So maybe try deleting something from Google Drive, but the file is really small. I don't see how that would be the case. Yeah, it's like 16 kilobytes, so it really shouldn't take up that much space. But yeah, try making sure that there's space on your Google Drive. And if that doesn't work, turn it off and turn it on again. Just go back to the website and re-upload it and see if it gives you anything new. Okay, yeah, so that is your problem. Maybe clear out your Google Drive or set up another Gmail account that has, because yeah, I think when you make a Gmail account, it gives you like 10 gigs for free or something like that. So maybe try with an account that has more storage, or maybe try deleting some of the stuff there. But it's really small, so you shouldn't have to delete much. It's like 16 kilobytes. Okay, perfect. Yeah, let me know if that helps. Awesome. Great to hear. Now it won't be very boring. Yeah, Colab is basically, it is Jupyter Notebook. They're actually exactly the same. If you've used Jupyter Notebook, you'll notice they're basically the same thing. The tools are slightly in different places, but it is the same thing. The only difference is Anaconda runs locally on your computer, whereas Colab is we're actually leveraging Google Server. So I'll show you in a second, but basically when you do 1+1, if you do it in Anaconda, your computer is crunching these numbers. Your computer is the one calculating the 1+1. When we're using Colab, it's actually getting sent to Google Server. And then Google Server, you can see here, this is how much resources are on their server. We're just kind of borrowing their server. And so we send them this code, it crunches the numbers, and then the result gets sent back to us here. So yeah, they both work interchangeably with our IPy notebook extension. For those of you that are curious, you can use any tool you want. You can use Anaconda is what we recommend just because it's the easiest to set up. Colab I use for these workshops because not everybody has it set up, and then making sure that everybody has it set up is a little time consuming. But yeah, if you use, I think someone mentioned they used VS Code, which has the IPython notebook extension to it. You can use that for sure. Spider, data grip. Data grip? Not data grip. What's the other one? Can't remember what the other one is called. But yeah, any kind of editor that can open IPy notebooks should be fine. PyCharm is the one I'm thinking of. Thank you. Yeah, Databricks owns both of those, I believe. They have data grip for SQL and then PyCharm for Python. So if you're used to those, feel free to use those. I'm just going to assume that if you know what that is, you know how to use it. And so, yeah, you should be able to just upload the notebook. Jerome would like to know if you can use other file types. Yeah, you can. You can definitely extract the data from things like that. So if you have like a chart in a PDF file and you want to just extract all the information, maybe you have a large PDF file and you want to extract certain words from those, you can do that in Python for sure. There are libraries that will allow you to do that. But the actual code itself should be written in either like an IPython notebook or like a .py script. But yeah, the code inside, if you want to process things like PDF files, documents, Excel files, CSVs, which we're going to do later, all of that can definitely be done with Python. No problem. Yeah, that's one of the big advantages of Python is that it's very flexible. You can actually use it to do anything. Almost anything. Oh, okay, it's 7:25. So let's continue. Hopefully, is everyone back? Yes. Would you be able to tell me if you're not back? Thank you for answering though. Okay, so if you're in Colab, what I'm going to do is we're going to work through this notebook. So again, I'm going to treat this like a real class. This actually is one of the lectures I normally do in the Python for Data Science full-time course. But I did water it down a little bit just because I know you're all beginners. But yeah, I'm going to treat it like a real class. And so how it's going to work is you'll notice there are these are called cells. So each of these blocks inside of a Google Colab or Anaconda is called a cell. And there's two types of cells. One is a text cell and the other is a code cell. The text cells are these ones here with all the text in it. And I'm just using that to display information. So you can see this, I'm just displaying information with those. And then you have code cells where we're actually going to type out code. And so the idea is I'm going to explain some piece of code to you. You're going to type it out with me. So I want you to get a feel for what you're actually doing. And so you're going to type out the code with me. And then further down, we have things like exercises. So you'll be able to try out the things you just learned on some real world data for yourself. And so I guess what I'm getting at is I want to treat it like you're learning how to swim or something like that. I could lecture you and give you PowerPoint slides and whiteboard a bunch of things on how to swim. But until you actually try it yourself, jump in the water and actually flail around for a bit, you won't learn how to swim. And so that's the idea here. I want you to actually try it out yourself so you can get a feel for it, so you actually understand what's going on. And then we'll have these brief pauses where you'll work on exercises yourself without my help. And hopefully you can figure those out as well. That's going to be the idea. And so if you click on File here, I'm just going to do a new notebook really quick just to show you what it looks like. But again, keep this one open. It should stay open in that tab. I just clicked on New Notebook just so I can show you an empty notebook. But yeah, if you want to do a text cell, you can add a text cell, and you can write your own notes here. This is mandatory, by the way. You have to type this out. Yeah, you can add your own notes using the text cells. But for all the code, press the plus code button, and then you'll be able to do things like 1 + 5, where we'll actually type out code. So yeah, that's really all you need. How to make a code cell, how to make a text cell. To run the cells, just hit the play button. There are some shortcuts. If you're lazy like me, you can do something like hit Command Enter if you're on Mac, or Control Enter if you're on Windows to run the cell. Control Enter if you're on Windows. So there are a whole bunch of these shortcuts. If you click on Tools and Keyboard Shortcuts, you can see all of them. But you don't need any of them. So for our purposes, you can just learn this one because it'll be a little faster if you do it this way. But you don't need any of the shortcuts. You can always hit the play button. If you want to delete a cell, just click on the delete. But yeah, I think that's essentially all we need. Good. Any questions so far? Okay, so we're going to be using a library in Python called pandas. That's going to allow us to do the data manipulation for us. So this isn't really a beginner Python class. For that, you'll need to look at elsewhere, because the goal of this class is for you to understand what a data scientist does, not what a programmer does learning Python. And so I am going to be using different libraries to perform some of the tasks for us. And the first library we're going to use, which is a very important one, is called pandas, which we use to do all of our data manipulation for us. So rather than explain it, I'll show you what it looks like. So the first step is to run these imports. And so again, understanding this is a little bit outside the scope of this project or this workshop. And so just trust that this is what you need. I'm importing some libraries that I need. Pandas to do the data manipulation, matplotlib to do visualization. So we're going to build some charts. But yeah, once you have that, you can run this line here. And I'll show you what it does. So if you make a new cell directly underneath and type out Titanic, you'll see the data set that I'm working with. So before we talk about it, let me just show you what this is. So in Python, we call this a pandas data frame because we're using a library called pandas. That's this PD part here. And in pandas, once you have a data frame loaded, they call it a data frame. And if you look at it, it's essentially a SQL table or an Excel spreadsheet. So you have multiple rows and multiple columns. So in this case, we have something like 1,308 rows by 14 columns. And so each row here represents a passenger on the Titanic. And so you have information like, what class are they? Did they survive? Yes or no? So if we wanted to build a predictive model, this is what we would predict for. Did that passenger survive? 1 meaning yes, 0 meaning no. You have their name, what gender they are, how old they are, if they have any siblings or spouses on board, how many, if they have any parents or children on board, how many. There's a ticket number, ticket price, and some other miscellaneous information. So again, we call this a pandas data frame. And so this is the kind of data type that we're going to be working with throughout this notebook. And so let's talk about how we actually did this. So how we accomplished loading this in is, I use this command here called pd.readCSV. So I'll actually show you, I'm going to scroll down to this help part. And so the function that we're using is called pd.read_CSV, just like that. And then we put a set of parentheses. Inside of those parentheses, we can access whatever attributes or parameters that you want to give to this function. So what the function is doing is it's loading in information, and particularly it's loading in CSV information. Can anyone tell me what a CSV is?
Comma separated values.
Perfect, comma separated values. That's exactly what it is. And so if you look at the file, I don't think I have the file, but this address that I actually pasted into the function itself, if you go to that address, you don't have to do this, but it will download the file. And actually, I'll show you what the file looks like after I download it. Oh, it doesn't open the way I want it to. Sorry, give me 1 second. Yeah, if you open the file in just like a text editor, like Notepad or something, this is what it looks like. Essentially, it's that table, but the formatting looks like this. So you have the header here with the column names, and they're all separated, if you can see, by commas. And then each row here represents one row in the data set, and those are also separated by commas. So it's just a way to format data. Does anyone know any other text-based ways to format data? We just talked about CSVs. Does anyone know any other ones? JSON, yeah, JSON's a good one. JSON, XML, yeah. So there's a whole bunch of different ways, right? You can do things like you can read in Excel spreadsheets. You can read directly from a SQL table. You can read HTML as well, yeah. So all of these formats are supported in using pandas. They just have different names. So for example, if I wanted to read in a JSON file, which is a different type, a data type, there's a pd.read_JSON, and you can use that function instead. If I wanted an Excel file, there's a pd.read_Excel. So all of these exist in Python because it supports a whole bunch of different file formats. Each format will have different parameters that you can put in here because they are stored differently. So for example, Excel has this idea of like sheets. You can have one Excel file with multiple sheets. And so when you do the read Excel, you're going to have to specify which sheet you want. Whereas CSV doesn't have that problem. And so there won't be a parameter for sheets. But if you wanted to see all of the parameters that you can pass in here, you can put a question mark at the end, so no brackets. So normally we use the brackets to put in the parameters. With no brackets, if you put a question mark at the end, you'll see it opens up the help menu. This will work with any function, actually. And you can see all of the different parameters that function takes in. So these are all the parameters. And if you scroll down, there's an explanation of how to fill in each of those parameters. So again, we're not going to go through all this. It's a lot of stuff. But an important part of data science and programming in general is knowing how to read this documentation. So if you do want to do this real, you should understand this. But for now, we're just going to focus on this first parameter here, which is the file path. And so that's what I'm putting in here. When I say pd.read_CSV, as a string, I'm going to put in a file path to where that file is. And so when you ran it earlier, this link here actually goes to that file. If you saw earlier, when I went to that link, it actually downloaded the file. So rather than downloading the file, this function will download it basically into your notebook and then display it for you. The reason I had to do it this way is because we're using Colab. It's a lot easier than uploading the file. But if you do want to run this locally on your own computer, so here I have a Jupyter notebook that's set up on my own computer, you can do the exact same thing with any CSV that you have by just doing read underscore CSV. And on my local computer, I actually put the file here, the CSV that I want to open up, into the same folder as that Jupyter notebook. If it's in the same folder, all I have to do is type in that name of the file. So I could just do titanic.csv. And that will do the same thing. That will load in the file as a pandas data frame. But yeah, because we're using Colab, I'm going to use this link just so that we don't have to upload the file anywhere. And so that's how we're loading it in. Does that make sense? Any questions so far? Okay. From there, you'll notice all I did was I took the results of running this function, and then I saved it to a variable called Titanic. So that's why I have to type out the Titanic, because now that's my data frame. That's the name. This could have been any arbitrary name we wanted to call it. Could have called it like data frame. Could have just called it X if I wanted to. But to keep things easy to read, I'm going to call it Titanic. Oh, there's a read PDF. Cool. So you can use that. Okay, so far you shouldn't have had to type anything, actually. As long as, just make sure if you're following along, run this one, the imports, and run this one to load in the data. So far we've accomplished the first part. So here, maybe I'll write it down somewhere just so we can have it in one place. We talked about how we set the objective. And then the data step, collect, clean, EDA, exploratory data analysis, modeling, which we're not going to get to in this lab, deployment. So yeah, so far we've worked on this stage. We've just done the collecting stage. But again, data can come from lots of different places. And if you're using pandas, you have access to all these read commands to load that data from wherever it originally comes from. PDF, I did not know you could do that. I'll add that in. Thanks, Jerome. So yeah, we've done the first. So the objective here is, for today, we're just going to explore the data and analyze the data and see what kind of interesting information we find. But if you do want to attend next Thursday, same time, I'll be doing the modeling side, so the machine learning side. So not only we're going to use the same data actually, and we're, instead of just analyzing it, we're actually going to use that data to also build a machine learning model. But yeah, for our purposes today, we've collected it so far. And some simple commands that we can use to take a look at that data. The first one I want to show you is .head. So if you take the Titanic data frame, you do dot, the name of the function, head, and then a set of parentheses to call the function. It should print out the first 5 rows. As a parameter in here, you can put in any number integer you want. So if you put in 3, it'll print out the first 3 rows. If you do 10, it's the first 10 rows, etc. If you put nothing, by default, it defaults to 5. Another thing you might want to do is after you take a look at the data, you might want to know, well, how big is the data? To do that, you can do a dot shape. Notice there's no parentheses at the end. But again, that's a little outside the scope of this workshop. To understand why that's the case, just know that for this one function, the next 2 functions, there's no parentheses. But yeah, if you do a dot shape, it'll give you back, this is the number of rows in your data set. This is the number of columns. Yeah, it does start at 0. So we'll talk about that index in a second. Actually, we'll talk about that next. So you'll notice, yeah, in the data frame itself, there's an extra column at the front that doesn't have a column name. So we call that the index. and you can extract that index by doing .index. Right now, it just tells you it's the numbers from 0 to 1308. So if you look at those numbers, it just goes from 0 to 1308. That's how many rows there are. But for certain tasks, you might want to change one of the columns to be an index. So for example, maybe I want to use name as an index. I can convert name to be an index instead. So we're not going to do that. We're just going to keep it the default, which is to use the numbers from 0 to however many rows there are. You can also get all the column names by doing the same thing, Titanic.columns, to see all the column names as a big list. And so these are all the column names. It's the exact same as the columns at the top when you print out the data frame. So far, so good. Any questions? Any problems?
Vinny, can you hear me?
Yep.
Is it possible to do like variable name completion?
Yeah, you absolutely can. So because I've defined this Titanic variable, if you just start typing sit Titanic and hit tab, it should autocomplete.
I tried that. That didn't work.
It didn't work. This dropdown is also like you can just click through the dropdown, or you can just hit enter. It's not enter. It should be tab though.
Huh. Yeah, that was I did that sort of out of instinct and it didn't work.
Actually, sometimes it works and sometimes it doesn't. I don't know what's going on either. You jinxed it. If you make a new cell, does it work the first time?
Let me see.
Then hit tab.
TNT. Not for me.
No?
No.
Okay, then we're screwed. Sorry, I actually don't know what the problem is.
Okay.
But yeah, it should autocomplete.
Hmm.
That's very strange that it doesn't.
Hmm.
Do you see the dropdown when you start typing?
No.
Not at all?
Nothing.
Okay, maybe your browser is doing something weird then.
No, I'm on Brave and Linux.
Oh, you're using Brave, okay.
Yeah.
Yeah, maybe Google doesn't like that you're not using their browser.
Okay.
Okay, that's unfortunate. But if you do install it on Anaconda, it should work. But again, yeah, maybe certain browsers don't allow that. Yeah, if you're used to computer science and some other language, C, Java, you'll know that it's statically typed. I think that's the term, where you have to declare the types. Python doesn't have that. It's dynamically typed. You just define the variable and it infers the type. But yeah, let's continue. So if you do a .info instead, this will bring up a bunch of information about your data frame. So it has how many rows there are, how many columns there are, and then a breakdown of each of those columns. And so pandas, by default, it will infer the data type for you. So it's going to read through the values in that CSV file that we were looking at, and then try and figure out the data types. So it found that the survived column is all integers, so it sets the data type to be integers. It found that the ages are all floating point values, which is just a decimal value, 8.5 years old. And so it sets that data type to be float. And then for everything else that it doesn't understand, it'll set it to be an object, which is just a string type. So just a sequence of characters. So for something like name, that's going to be object. It's a sequence of string of characters. Sex, object type, sequence of characters. And so that means, like, for example, you won't be able to calculate, say, a mean, the average value on something like name. That wouldn't make any sense. And then down here, it summarizes how many of each there are. Python is smarter. Depends on who you ask. If you ask like hardcore programmers, they hate Python because of this fact. But I think it's okay, especially for beginners. Python is a great language because it hides away a lot of the complicated parts for you. But yeah, the last thing you can see here is the memory usage. Does anyone know what this is? Why is it useful to know the memory usage? Can you tell me what memory is on your computer? Or how much of it you have? Yeah, in case you have limited RAM because you're going to run out of memory. Exactly. That's the exact error you'll get if you try to load in more data than you have memory. And so your computer has two types of storage, right? It has disk storage, which is probably very large. Maybe you have like a terabyte, 500 gigabytes or something like that. And then you have a much smaller part of your computer called the random access memory, RAM, or the memory. Maybe you only have 8 gigs of that, 12 gigs, 16 gigs, something like that, significantly smaller. But your RAM is a lot faster. And so reading and writing from your memory is a lot faster, and that's what Python uses. So it's going to be quick to make calculations because it's leveraging your memory. The downside to that is you have a limited amount of memory. And so if you try to load in a data set that's too big, you have 8 gigs of data or 8 gigs of memory, and you try to load in 10 gigs of data, it'll crash. Or if you try to do a calculation that uses up more memory than you have, then it'll crash and you'll get an out of memory error. And so this is useful to know because, yeah, you don't want to load in data that's going to be too big. And so you can see this data set is relatively small. It's only 1,300 rows, and it only uses 143 kilobytes. So not even a single megabyte yet, which is 1,000 megabytes makes a gigabyte. And so you have way more memory than you need to load in data of this size. So if you're using something like Excel, I think there's like a 1 million row limit. Python should be able to load in 1 million rows perfectly fine if you have like 8 gigs of memory. If that didn't make sense, don't worry too much about it. Just know that you have a certain amount of memory on your computer. This tells you how much of it you're using. If it's too much, it'll error. Good. Any questions? By the way, if you run a cell and you click on this little box on the side, you can hide the output in case your notebook gets cluttered. Okay, so the next thing we're going to use is this .describe method. And it's just going to give us some summary statistics. So for every numeric column, so these are the columns that are numeric. So if you look at the info, the numeric ones are the ones that are integers and floats, because those are the ones it makes sense to calculate these metrics. And so it just gives you some summary statistics. It calculates things like the mean value for that column, the standard deviation, the minimum value, maximum value, the median value, and some quartiles. And so, for example, if we're looking at age, you can see the average age is roughly 30 years old. The lowest age is a person that's 0.17 years old. The oldest person is 80 years old. So this is like a very preliminary EDA step. It's our exploratory data analysis step. We've loaded in our data. Now we're just taking a look at it. We're getting a feel for understanding our data, because that's going to be the most important part. Anything we do from here on out, if we don't understand our data, probably won't be good. Good. Any questions there? Why are there? Yeah. So there's actually less ages than there are actual rows. And so we'll find out later that a lot of them are missing. And so that's going to be part of our cleaning stage. We're going to have to actually clean the data because it's missing a bunch of values. So yeah, good point. Keep that in mind. Okay, but let's continue. So we have this Titanic data set. If you print out the whole thing, it prints out this giant data frame. You'll notice it does something weird in the middle. Does anyone know what's going on in the middle here? So it gives me rows 0 to 5, and then this ... and then the last 5 rows. So the reason is because it's basically just hiding these rows away from you. Because if you have like 10 million rows, you probably don't want to display all 10 million in your browser. It'll crash your browser. And so it'll only display the first 5 and the last 5, and then just hide the ones in the middle. It's truncating those values for you. But yeah, let's say we want to analyze or take a look at a particular column from our data frame. If we wanted to look at a particular column, let's say we want to look at the age column, all you have to do is after the name of the data frame, you put a set of square brackets. And then as a string, so to make a string, you put in the quotation marks, and then the name of the column you want. So you can see it actually auto-completes here with all the column names. You could just select it from here or type it out. So if I wanted to look at the age column, you would do that. So you can see already, there's a whole bunch of ages, and then it truncates some of the values in the middle, so we don't display too many. And you see this NAN here. Does anyone know what this is by any chance? It stands for not a number, which
It's a missing number.
Yeah, that's exactly it. Orelli was a cool name. Is that how I say it? How do I say your name?
Yeah, Aurélie.
Orelli. Yeah, it's a missing value. And so in the actual original CSV file, that person doesn't have an age. It's just an empty, a blank spot. And so in pandas, this is how it displays the empty values, the missing values, as NAN. It stands for not a number. And between Aureli's and, I can't remember who said it earlier, somebody mentioned that there's only 1,000 ages that actually have values. Actually, I'll show you. When we did the .info earlier, it tells you how many non-null values there are. So null meaning that it's missing. These are how many non-missing values. So these ones have all of the values, but you can see for age, it actually has less than the total, 250 less roughly. And so that's where the 250 are. They're actually missing values. So we might want to do something about that. We might want to clean that data up. Yeah, if you want to select multiple columns, so maybe I want to know the person's age and the person's name. The way you do that is you type in the data frame, put the same set of square brackets, but you're also going to put another set of square brackets in between, and then just list out the ones you want. So if I want to know the person's name, their age, and their fare, it would look something like that. So you put a comma to separate the columns that you're listing out. And so now you can see it gives you back a new data frame with just those 3 columns. So far, so good. Any questions? We're okay. Yeah, it's kind of confusing assuming you don't know Python. If you do know Python, the outside one is how we're making the selection. So we're saying from this data frame, give me back something. So in this case, it's 1 column. But the inner set of brackets is actually a list in Python. So we're actually listing out the values. In Python, lists are designated by square brackets. If that doesn't make sense, I wouldn't worry too much about it for now. Cool, no problem. Okay, so that's how you get the column names. And it turns out the syntax we're using here, the set of square brackets, is actually a shortcut for another function. And that function is called LOC. And so if you do .loc, square bracket, inside of the square bracket, it takes in multiple parameters. But let's put in 1 parameter first. So if you just put in a single parameter, let's say the number 3, this is the 3rd row of our data set. So if I'll print out the first 5 rows of the data using head, so you can see the first 5 rows. When you do .loc, square bracket 3, this gives me back this exact row, the row where the index is 3. So you can see it's Mr. Hudson, Joshua, Creighton, Allison. Mr. Hudson, Joshua, Creighton, Allison, along with all that person's attributes. It's literally just this row displayed a little differently. You can extend the syntax. So if you put in a number and then a comma and then another number, I put a space here, you don't have to. But if you put in another number here, the first number represents which row I want. The second number represents which column I want. So if I wanted to know, for example, the third row, this particular passenger, and I wanted to know what their name is, as a second parameter here, I would put comma, and then as a string, so using the quotation marks, name. So you can think about it like a grid system. First pass in the index, then pass in the column, and then that gives you that exact value. We can further extend this by using the colon. So again, I'm going to put a comma here for two different pieces of information. The first is the rows, and the second is the columns. Don't type this part. But that's what those numbers represent. Row 3, column name. But you can actually extend this rather than just a single number like 3. If I wanted row 3 to row 7, for example, I could put a colon in between. And here, I'll do this without the columns so you can see it. But you just have to put a colon in between, and it's called slicing. We're basically slicing out row 3 to row 7. You can do the same thing with the columns. So I can say, give me column survived to column ticket, and it would slice out these columns here. But not only that, you can also list out the ones you want. So if you put in another set of square brackets here, just like previously when we selected multiple columns, I can list out the ones I want. So if I wanted to know the person's name, age, fare, it would look like that. So again, how you read this is I'm using the .loc function to locate certain pieces of information. The first parameter tells me which rows I want. By putting a colon in between, we're saying slice out the rows from 3 to 7. And then the second parameter after this comma here tells me which columns I want. I can put in a single column. I can slice out the columns by using the colon, or in this case, I'm listing out the columns. So I put another set of square brackets and then list out the columns I want. So you can mix and match each of these. Yeah, so if you wanted non-sequential rows, you would have to do something like this. So in here, you would put a set of square brackets and then list out the rows you want. So here, maybe I'll put that in a different cell. So this cell does that. Do another one where we just want rows. So again, another set of square brackets. I just want rows 3, 5, and 7. So I'm not slicing from 3 to 7. I want exactly rows 3, 5, and 7. Is LOC an abbreviation of location? That is a great question. In my head, that's what it is. I don't know if that's actually true. I would assume so. I would assume so. If it's not, hello.
Study pa ako dyan.
No, that's not for me.
No, gas pinggan.
Sorry, Francis. I'm just going to mute you for a second while you yell at your kids. If you do have a question, though, feel free to turn that back on. But yeah, does this make sense to everyone? Perfect. Okay, so again, hopefully make sure this makes sense because you're going to try it out yourself on some data later. You want rows 10, 20 to... Okay, so you want to basically condition the number of rows, right? That's going to be a little bit more involved. But I'll show you some ways that you can do that a little later, okay? Yeah, iLock is a little bit outside the scope of what I wanted to talk about. But if you're curious, iLock is the same thing. There's an I in front. But if you put it in like this, it'll error. It tells you that it requires an index. Because what it expects is, rather than the actual names of the columns and rows, what it expects is the position. So I want column 0, column 2, and column 4, let's say. So column 0 is P class, column 2 is name, column 4 is age. So iloc uses the position of the column names and the positions of the rows rather than the exact. So you can see here we're using the actual names of the columns. Whereas if you use iloc, you're going to be using the position of the columns. So what position is the column in the data frame? Column 0, column 2, column 4. But yeah, I didn't want to confuse you because the index is the same. But yeah, if this doesn't make sense to you, don't worry about it. Most of the time you're going to be using LOC anyways.
Can you scroll up a little bit? I just want to check something. Can you just a little bit more higher?
Just minimize these so you can see them.
Yeah.
Higher?
Just a little higher where you selected multiple.
Oh, this one here?
Yeah. Okay. Okay. Sorry. Perfect. That's good. Yeah. I was putting the wrong sort of yeah, commas there.
Brackets?
Okay.
Yeah. Okay.
Yeah.
So the number one error, 95% of your errors right now, if you're new to programming, is going to be this. You're going to forget a bracket, or you're going to use the wrong bracket. Maybe I use a parenthesis instead of a square bracket. And I don't have a good strategy on how to fix this. Besides, you're going to have to just do it a lot until you get a feel for it.
Mhm.
It's like swimming. I can explain to you how to do a front crawl all I want, but until you actually try it, you won't remember. So yeah, for now, you're going to struggle with typos a lot. But as you do this more and more, which hopefully you want to, if you want to be a data scientist, it'll become second nature, which brackets go where. Good, any other questions? Okay, so I'll do one more and then we'll do an exercise and take a break as well. So I like to do like a 10-minute break every hour roughly, because I know it's not easy just sitting there for 3 hours straight for all of us, me included. And so yeah, after this, we'll take a break as well. So the next thing we can do is, let's say I wanted to know, so from this age column, I want to know everybody in the data set that is over a certain age. Let's say over 18. If they're over 18, maybe we can consider those people adults and we want to analyze whatever information about adults. Maybe we have a hunch, if you've seen the James Cameron movie, you know, women and children first. And so maybe I want to know, is that actually true? Did children survive more on average than adults? And so if we want to answer those information, we're going to have to filter out the table by removing certain ages based on some kind of condition. And so to put a conditional here, in Python, we use the angle brackets. So this is less than, this is greater than, this is less than or equal to, this is greater than or equal to, and this is exactly equal to, a double equal sign. So I'll show you that again in a second. But let's say it's greater than or equal to. I want to know the ones greater than or equal to 18 years old. Let's say that's what we consider the cutoff for an adult. Actually, in Canada, what is it, 19? Let's say 19. They can buy cigarettes and vote. As soon as you put this condition here, if you run it now, what it's going to do is it's going to return a Boolean value. So a Boolean value is just a true or a false based on whether this condition is true or not. So the first one, because it is greater than 19, that will return true. This one is less, so it'll return false, false, true, true, etc. So when you run that, that's what you're going to see. And then if we want to filter out the entire data frame based on this condition, so I want all the rows in my data frame where the passenger's age is greater than or equal to 19, all I have to do is put this in a set of square brackets again. There's a lot of square brackets, I know. It's confusing now, but once you get the hang of it, it's not too bad. And then you're going to put the name of the data frame again in the front. So I'll show you what that looks like first, and I'll explain it again. But yeah, you can see the data frame is now a lot smaller. The original one has 1,300. Now we only have 900 roughly. So we eliminated a whole bunch of them, a few hundred. And you can see if you look at the age column, there's only people greater than or equal to 19. And so the way you read this in pandas is basically you're saying, give me back the pandas data frame Titanic, square bracket to do the filtering. This is kind of like saying where the age column is greater than or equal to 19. And that gives you back a new data frame that matches those conditions. If, for example, you wanted multiple conditions, so I'm just going to hide this output, but I'll leave the code here if you need it. Oops. Just going to copy and paste the same thing, actually. And the only difference here is inside this set of square brackets. If I want multiple conditions, I'm going to wrap them in a set of parentheses. So if I have two conditions, each of those conditions is going to be put inside of its own parenthesis. Again, I know there's a lot of brackets and they're all different. I think we used all of the brackets. No, we're missing curly braces. But let's say that's your first condition. And let's say you have another condition. Let's say I also want to know the ones where the person is male. So that information is in the sex column. And inside of that column, we just need to check, is that person male, by using the string male. So I'm going to wrap that in another set of brackets. So now I have one set of brackets here for the second condition, one set of brackets here for the first condition. The whole thing is in one big square bracket. And then in between, we're going to put a logical condition that we want. We can either do an ampersand for and. So that means both of these conditions have to be true. They're over 18 and that person is a male. And so if you run that, that's what you'll see. All the sex is male and all the ages are over 18. I'm going to make another one directly beneath it. And the only difference is I'm going to change this ampersand to be the pipe symbol, which is the key right above the enter key. Hit shift, and then you should get this pipe. This is an or. So this basically says either of these conditions can be true. They can be 19 years old or they can be male. So you'll see it also includes females that are over 18, and it will also include males that are under 18 because one or the other of the conditions is true. Does that make sense? Can we filter the columns that we're interested in? Yeah, for sure. So because this returns a single data frame, you can just chain on that command. So just like before, if I just wanted the name column, sorry, I got to scroll up. You put a set of square brackets afterwards, and then the name of the column. You can do the exact same thing here. After you do all your filtering, this is a data frame. And we know that to select from a data frame, you can just put a set of square brackets and then the column you want. So if it's age, you could do that. So this is all the ages of the people where both of these conditions, or one of these conditions is true. Yeah, I'll remove that so it's not confusing for everybody else. Good. Any other questions before we try it out ourselves? Okay, cool. So let's try it out. And then if you do have any questions, feel free to ask. That's the point of this. The point is so you can try things out, make mistakes, and then we can go over how to fix those mistakes. The other nice thing about data science, or programming actually in general, is that it's cheap. If you want it to be like a chemical engineer, you probably require a lot of very expensive equipment. And then if you want to run experiments, every time I use that vial of whatever chemical, that costs money, right? With programming, everything you do is completely free, right? We're using a free service, Google Colab, or if you install it yourself, we're using free Anaconda. And running any of these programs costs a minuscule amount of electricity, which is essentially free. So feel free to just run things and break things, make as many mistakes as you can, because that's how you learn. And so what we have here is I have another data set. So again, I did the first question for you because if you're on Colab, it's kind of hard to upload the file. So I actually had to upload the file to a URL for us. But if you are doing it locally, you can download the file manually yourself and then load it in using read CSV. And then I just have some simple questions, but using this data frame instead. So I'll let you play with it. So make sure you run this first. Once you run it, you should have access to this prime data set. Take a look, see if you can figure out what all these columns do, answer the questions, play with it. So pretend you're doing your own kind of EDA stage. Does that make sense? Does the question make sense? Any questions about the question? Oh yeah, this is outdated. If you do want the exact data frame, it's under Open Data MCI. It should be one of these. But yeah, they include a whole bunch of extra information that we don't really need to deal with. So you don't actually need this, but if you are curious how the data is collected, all that information should be in there. But we're only using these few columns anyways, so it shouldn't be that complicated. Good. Any other questions about the question?
If you can go back to the first 3 rows, I think I kind of missed like the declaring how to get the first rows dot head.
Yeah, for sure. So once everybody's settled in and they can work on this, I'll scroll back up and you can see everything in one place. Okay. Yeah. Any other questions? Okay, so I'll give you some time to do this. So let's say work on this exercise. I don't think it takes too long, but take a break while you're at it too. So we'll say exercise plus break until 8:30. Randy's got to go. Okay, Randy, take care. Thanks for coming. But yeah, so exercise break until let's say 8:30, okay? And then we'll come back and we'll discuss, and I will scroll back up. Oh, I can't fit everything on one page. So if you're actually attending this class, I have another page that just mirrors what I'm doing. And then you can copy and paste all the things I type out of that. But because of this workshop, I don't have that. So you're gonna have to, I'll leave it.
I think I missed, hold on, like get first rows and then data frame, dimensions, index, columns. Yeah.
Okay, so I'll leave this portion up for maybe
Okay, perfect.
5 minutes, and then I'll scroll down if you missed the other portion.
Thank you.
No problem.
Get first rows, head, okay. See.
Man wants to know page that mirrors. Oh, so I'm just saying, I was just saying, like normally in the actual lecture, I have another page that mirrors this page, and I send you that link, and you can just copy and paste out of that link. Unfortunately, I didn't have that set up for today, so you'll have to deal with me scrolling up and you copying it out. That's all. Is there an alternative to .loc? Yeah, I mentioned there's a .iloc if you want like column number 2 rather than the name of the column. But other than that, those are the 2 functions that you would use to slice out certain portions of the data. Yeah, but you can mix and match them, right? So we used LOC to slice out, for example, this row to this row with this column to this column. But if you want to have a condition in there, this row to this row, this column to this column, where the age is greater than or equal to 18, you can combine both of those into one long query that will extract all of that information. Like a chain, exactly. Yeah, you're just training on the commands one after another. No problem. Are we doing the transforming data section 2? What did I say? Sorry, scrolled. Just this section, just exercise 1 for now. Yeah. So questions 1 to 7. And then we'll continue after the break. Yeah, so this stuff you need me for. So hopefully you have that first part. If you don't, let me know. I'm going to scroll down to the second part in case you missed any of this.
Yeah, I'm good. Thank you.
Good. Okay, no problem. Just wondering, when does data wrangling become more complex in Python pandas? Yeah, so right now I'm just teaching you the basics, which is learning these commands, but the way you mix and match these things and how you combine them to extract even more specific pieces of information can be as complicated as you need it to be, right? So if you're just doing simple things like calculating a mean, then that's as easy as a simple command. But if I need to slice out these rows and these columns, and then take this column and add it to another column, and then do some kind of transformation on top of that, that could get very complicated, right? And so if you look at, if you just type in pandas documentation, it's actually quite good. Here, maybe I'll send this to everybody. I'll also mention it again when everyone comes back from the break. But yeah, there's this 10 minutes to pandas, which is kind of like what we're going through now. So it shows you some of the basic commands and how to use them. And these portions of code are actually, like, you can run these. So if you just open Colab and then you type these, copy and paste these lines of code in, it'll work. And then you can try out all their example codes, and they have explanations of what's going on here. And so that's the 10-minute little introduction. And then if you want to do anything more complicated, they have a breakdown of each of the topics. So for example, if I have multiple tables that I need to merge together, these are all the ways that I can merge and combine them. If I'm working with, say, text data, these are all the different available functions and how to use them. And so yeah, a lot of, not just data science, but programming in general is, it's not memorizing all these commands. I don't know all the commands. I don't think anybody knows all the commands. It's also a waste of time to learn all the commands. What's more efficient is just learning them as you need them. And so the ones that you use more often, you'll end up memorizing anyways, because you've used them over and over again. And for the ones that you don't know, you can always just look it up in the documentation, which is a lot better, I would say. Yeah, no problem. what are some of the things that only SQL can do that Python can't? That is a great question. Nothing. I would say pretty much everything you can do in SQL, you can do in Python. The difference is in what you want to do with that data. So because Python is a lot broader, it can do a lot more things than just database management. But that very first stage, that collecting stage, because it's stored in a SQL database, you still need to understand SQL. And so those SQL queries, select star, from, table, where, whatever, you still have to understand that stuff because you're still going to have to use that information to pull the data out of SQL in the first place. And the reason it's usually in there in the first place is because I don't want to store my data like this. I don't, as when your company gets big enough, I can't store all my data as CSV files. It's not safe. I will lose information. It's not going to be secure. And so you're going to have to put it into SQL. And then the advantage of having it in SQL is that it's a lot bigger. So I can store much bigger portions of data because it's not reading and writing from memory. So if you remember, when you do a .info, if I have more data than I have memory, it'll crash. So if I'm working with, like, I don't know, 20 gigs of data and I only have 8 gigs of RAM, SQL will actually be better for that. It will be able to process that, not super quickly, but it will be able to process it without crashing, whereas Python won't. And so, yeah, part of it is because all the data is there to begin with. Part of it is because I can manipulate more of that data. And so unfortunately, you still need to understand those queries, even if you're going to use Python to extract the data from SQL. Yeah, we teach both here at WeCloud. So I find that there are two types of students. One type is they love SQL because it's very logical, and there's only like 10 keywords or something like that. And so you use those 10 keywords to basically accomplish everything. But for some students, that's really difficult. For me, for example, I find that very difficult, trying to manipulate those 10 symbols to extract the information I need. And Python is a lot easier because I can do everything kind of step by step. And so I'll end up doing everything in Python. But I'll still need to know SQL to get that data out of there in the first place. Sorry if I missed this. Oh yeah, so just this exercise. Yeah, where I'll do transforming data with you later. How can you search for text that is non-case sensitive? That's a good question. Yeah, so by default, pandas is going to be case sensitive. And so if I wanted, for example, to extract the single lat column, I do have to use the capital L. If I use a lowercase l, it will error because it is case sensitive. Unlike SQL, SQL is not, I believe. If you want it to be not case sensitive, it's not that easy. You'll actually have to take that column. No, actually, I lied. No, sorry, there's not a good way to do this. You'll basically have to rename the columns to be the lowercase version if you want to do this, which requires a bit of code. Yeah, unfortunately. So yeah, it is case sensitive. So if you do want to make everything the same case, you'll basically have to change the names of all the columns. But that's most programming. Pretty much all programming is case sensitive, except for SQL for some reason. Okay, so I'll give another 2 minutes for everyone to settle in, and then we'll go over the solution together. But in the meantime, if you guys have any questions, feel free to ask me. I'm just hanging out here anyways. Tim just wants to know what? What? Oh, okay. You pressed enter too fast. What's the best way to understand parentheses versus curly braces? Yeah, so these brackets, they all do have a meaning in Python. And so right now we're just learning this library called pandas, which uses these brackets a little confusingly. If you know Python, it should kind of make sense to you why they use these brackets. But yeah, if you do want to understand why these brackets are the way they are, you'll have to learn basic Python. So right now I'm not teaching you basic Python. This is using the pandas library through Python. But if you learn just like standard Python, you'll understand what the differences between all the brackets are used for. And pandas just borrows that syntax from there. But if you're curious, usually the parentheses are for like if I want to call a function. So like dot head parenthesis to call that function. Read CSV parenthesis to call that function. Square brackets are things like if I want to select or list out items. The curly braces you'll use if you have like dictionaries, if you know what that is. But yeah, they do all kind of have a meaning, and some of them are used in different ways too, which gets kind of confusing. But again, yeah, the more practice you get in doing this, the more it should make sense which ones are which. Okay, so 8:30, let's continue. Let me just zoom in a bit so you guys can see a little better. So we have the reading part, that's our collecting data part. And then we have show the last 10 rows. Did anyone figure this out? How do I show the last 10 rows? Just shout it out. Tail. Yeah, it's actually in the question. But again, the idea is you should get used to, this is not a set of square brackets, this is a parenthesis. And then you can input that parameter in here. Tail 10, perfect, exactly. So this is the last 10 rows. And so what this data frame is every row represents an instance of crime. And so you have things like, when did the crime occur? When did they actually report the crime? So those are two different numbers. Some geo coordinates, so the latitude and longitude of where that crime occurred. A neighborhood, so this is just a breakdown of Toronto by different neighborhoods. The premise type, was it outside, inside? Was it at a commercial building? Was it in some kind of other place? And then this MCI here stands for major crime indicator, which basically is going to be what type of crime it is. So if you look through this, you'll see things like auto theft, burglary, assault. And so there's like 5 different types of crime. And so in next week's workshop, what we're going to do is we're going to build a machine learning model. So using this information, can we predict what type of crime it actually was? So this is the thing we would predict for. Kind of like how in the Titanic data set, we're using all of this information to predict for whether or not a passenger survives. That's the idea. Cool. So hopefully that worked for you, Tail. How many rows and columns are in the data set? So how do I figure that out? How do I figure out how many rows and columns there are in total? Yeah, dot shape. So I can say crime dot shape. And so you can see it's significantly bigger, right? The other one only had 1,300. This has 130,000. So 10,000 more, or 10,000 times as much. And so significantly bigger. 10,000 times? 1,000 times as much. My math is bad. You can figure out that. But it's significantly bigger is what you can see here. So much more rows. But you can see all the commands we're running happen almost immediately. So for 100,000 rows, Python should be perfectly fine. It shouldn't be slow at all. When you get into the millions, maybe it slows down a little bit. Tens of millions, hundreds of millions, that's when it's going to start slowing down a lot. But again, it will be dependent on how much memory your computer has. So if you have the memory, if you have like, I don't know, 50 gigs of RAM, you can load in probably 100 million rows of data if you wanted. So speaking of memory, how do I check how much memory this data frame does take up?
Info.
Info, perfect. So I can say crime.info. So we can see a breakdown of each of the columns, what type they are. So it looks like most of them are strings, they're object types. The only two columns that aren't are the latitude and longitude. And you can see the memory usage is significantly more. The other one was in kilobytes. This one is 7 megabytes. But again, you can see it's not that much. Okay, now if I want to show the summary statistics, how do I get those?
Describe.
Describe, perfect. So in this case, it's not super useful knowing the average latitude and longitude of crime. I don't know, maybe that is useful. Don't go to this area of Toronto. No, that's not how geography works. But yeah, so this probably won't be super useful. But if we had more numeric columns, maybe we could analyze this to see other things. Which is actually what we're going to do further down, actually. We're going to generate new columns of data, and then it makes more sense to grab the summary statistics for those new columns. Cool. What's the next one? Select the latitude and longitude columns and rows 100 to 200. Anyone want to help me out with that one?
Look.
Yeah, .loc, square bracket, and then what do we do next?
The range.
Yeah, so we put a comma because there's going to be two pieces of information. The first one is going to be the rows. So we need the range of the rows. And so that's 100. And then we use a colon to say to 200. You can test that this works first by just running that. And you can see row 100 to 200. So that by itself works. But also if you want to add in the columns, how do we do that?
You have to put the name of the column in a...
Yeah, in which brackets? It'll be another set of brackets. It'll be
the apostrophe. Yeah, bracket.
Yeah, with the apostrophes, with the commas. Yeah, symbols are confusing. But yeah, it'll be another set of square brackets. And then inside the apostrophes, we list out the ones we want. So it'll be lat. So this is case sensitive. Make sure you put capital L lat, comma, capital L long. And you should get something that looks like that. Perfect. Okay, and one more. I want to know, select only the rows where the premise type is house. So if you look at crime and you take a look at that column, premise type, you'll see there's lots of different premise types, but the ones that are specifically called house, how do I filter those ones out or filter those ones in? I guess.
Equals equals.
Equals equals. Perfect. And then as a string, yeah, house, right? So if you just do this part, what's going to happen?
Syntax error.
It won't error. This will work, but it's going to do something different.
Okay. I didn't try.
You didn't try, you just memorized the command?
It's just going to say false or true.
Exactly.
So we need to create the data frame and say crime and open the square bracket again, crime.
Perfect. Yeah, that's exactly it. So this will return a true or false, depending on if this condition is true, right? So this will be false. It's not equal to house. This one will be true. It is equal to house. True. False, 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 etc. So that's what you see here. And then we put another set of square brackets around this, and we type the name crime again at the front. So the way you read this is give me the crime data frame, where the crime premise type column is equal to house. And that's what you should see. All the premise types are now house. Yeah, Bing Chang has the right code. Does that make sense? That's all the questions that I have for you. Hopefully that gave you a feel on how to type these commands. Hopefully you don't hate figuring out all the brackets too much. Okay, any questions about anything we've covered so far? Okay, so I want to leave the last maybe 15 minutes. We're supposed to end at 9, so maybe in like 5 minutes. I want to leave it open to Q&A, and if Xiaohua wants to talk about the courses, I'm not sure. But yeah, I do want to leave that last section for that. And so we're not going to be able to finish all of this. But if you do want the rest of this information, just come to the next workshop. It'll be on May 19th, where I'll talk about machine learning. And I'm actually going to use the same notebook. I'll fill in the rest of the code so we can work through it. And then we'll actually down here, we'll actually include a machine learning section. So we're actually going to build a predictive model. Can we predict if a passenger survives or not based on their information? And can we predict what the type of crime is based on this information? So that's going to be the next workshop. But for now, just to give you an idea of what some of this other stuff is, here we're just going to end up transforming some columns. So far, all we've done is we've just taken a look at each of the columns, but we haven't changed any of that information. So down here, that's what we're going to do. We're going to change some of the information. We're going to clean up the data. So here, we'll do this next time. But there's a bunch of missing values in the age column. And so we're going to fill in those missing values. That's going to be part of our cleaning stage, because we're going to need to fill those in to do the machine learning later. And so I'll show you how to do that. If you know any SQL, we're going to do a little bit of group bys and aggregations. And I'll show you how to actually save this file. So if we transform some of the information in here, I'll show you how to save it so you can continue from the next time. Bye, Shlomo. Is that your real name? But yeah, thanks for coming. And then, yeah, you'll work through the exact same thing using the crime data set. I'll show you some visualization as well, but I'll show you really quickly just how easy this is. So in the Titanic data set, let's say I wanted to know, for example, what is a good example? Let's say I wanted to do a histogram. So I want to build a histogram to take a look at the age column. So I would just select the age column, and then I can just use the command .plot. And then I can say, what kind of plot do I want? And in this case, I want a histogram. And that's it. So if I wanted this information as a line chart, I could just replace this as line. If I wanted a pie chart, replace this with pie, etc. So for example, I'll show you another command. If you do something like this, and I want to know how many males there are and how many females there are. Does anyone know how I could figure that out by any chance in pandas? Or in SQL, what would you do for SQL if I want to know the total number of females and the total number of males?
Count.
Yeah, you could do like a group by an account, right? In pandas, we call that a value counts. So there's just this function called value counts, which does exactly that. It'll group together those categories and then give you a count of how many there are of each. So inside of our data frame, there are 842 males, 466 females. And then if you wanted to plot that, you could just chain on the command here at the end, .plot, where we could say kind equals And let's say you wanted that as a pie chart instead. And so yeah, because we're using these libraries, so we're using the pandas library to manipulate the data. And actually we're using a library called matplotlib. If you saw at the top, sorry, I gotta scroll up. If you saw at the top, I actually imported this library called matplotlib. That's the library doing the visualization for us. So we're combining pandas here with matplotlib to create these charts for us. And so yeah, you can play with these things. The commands aren't super complicated to do this kind of stuff. If you want to combine it and make it more complicated, you will have to learn a little bit of Python too. So right now we're not doing basic Python. We haven't written a single for loop or anything like that. We're just using the pandas library. But I think it's better to learn it that way, because once you have an idea of what you want to accomplish, you can go in and figure out what code I need to accomplish that, rather than just learning like, you know, random snippets of code that you're not going to use to do anything with, and then you're going to forget them. Does that make sense? Okay, cool. Sonia, did you want to add anything?
No, I'm okay.
You're okay? Okay, so for everyone else, if you do have any questions about the courses, or you just want to learn a little more about whatever, you can reach me at that's my email. I particularly teach the full-time data science bootcamp. I think Sonia mentioned this earlier. It's 3 months, but really it's like 6 months with the co-op portion, where we go through all of this stuff. We learn SQL, then Python, Python for data science, which is this stuff, machine learning, and then cloud tools, big data stuff, all of that stuff. So I think the next batch starts end of this month.
Yes.
When does it start, Sonia?
It starts on Tuesday, May 24th, so in 2 weeks. And then we also have a part-time bootcamp that starts in June, so June 15. We do have pre-bootcamp materials to help students get up to speed. So, you know, when you register, the teaching assistant or TA will be helping you go through the materials within the time before the bootcamp, and will help you plan out how you can best prepare for the program.
Perfect. Thanks, Sonia. Yeah, if you have any particular questions about the courses themselves, you can reach us at info@WeCloudData. But if you have personal questions for me, I guess, you can email me here. So I teach this course. But yeah, we do this a part-time one as well. You can reach me here. This is the one I teach. But there are other corporate courses. There's a part-time course during then. We also do a lot of like corporate training. I teach those as well, if your company is interested in learning more. Or, you know, if you just want to chat or invite me to your birthday or something, you can email me. No one has ever taken me up on that offer, though. But yeah, I think that's, oh yeah. And so workshop part 2, machine learning. If you want to continue this lecture, we will have a little more time to talk through this stuff, and in particular in the machine learning side, that will be, sorry, Sonia, I need your help again. Is that May 19th?
Yeah, Thursday, May 19th. So I just posted the link in the chat. Vinny will be giving his machine learning introduction. So part 2 of today. And then if you go on our meetup page from there, we do have a couple more upcoming events. The ones, if you're interested in data science, the ones that are relevant to you might be, I'm just quickly finding them. We do have one on May 30th. Which is data science best practices. So Xiaohua, our CEO of WeCloudData, is going to be giving a talk on what are like some of the best practices in data science and how you can follow those. And then on June 7, we have an introduction to big data. So again, Xiaohua is going to be giving a talk on Amazon Web Services or AWS, and also talk about Apache Spark. So we'd love to see all of you there in our future events. If you're interested in joining them, I sent the last link, which is just the general page for those. And then if you do have questions specifically about data science or about the program as well, you can email me. My name is Sonia and I'm the data science program manager. So I can also give advice on like if you want to switch into this career or, you know, if you just have questions in general, I'd be happy to help you out.
Perfect. Thanks, Anya. Okay, so I think that's it from us today, but I'll hang out till 9 if you have any other questions, if you want to talk about anything else. But for everybody else, feel free to enjoy your evening. And you know, it's 9 o'clock, it's late. But yeah, thanks everyone for coming.
Thank you.
Thanks, guys. Yeah, I'll hang out for another 10 minutes if you guys have any questions about anything.
Yeah.
Steve, you got a question?
Yeah. Benny, this is Steve. Let's see, how do I frame this? I am looking at choosing different libraries. So I have the challenge of PyTorch, scikit-learn versus let's see what there's another one that's very similar. I want to say TensorFlow.
Mm-hmm.
I was wondering if you compared those for different utilities in some of the deep learning.
For sure, yes. So so here, I'll list out some of the libraries that are useful. So we just did pandas and matplotlib. For machine learning, we use a library called scikit-learn.
Right.
But if you're doing deep learning particularly, I would say that this isn't going to cut it. The deep learning in scikit-learn is terrible. Don't bother. So the two main most popular libraries are TensorFlow and PyTorch. So I think you mentioned those.
Yeah.
This one is a little bit more engineering focused. It's invented by Google. They like, building large scale engineering problems. That's what they're known for. That's what they're good at. And so that's how the library kind of is written. And then PyTorch is a little bit more academic. So it's much more Pythonic. If you're used to Python already, PyTorch is basically NumPy with fancy deep learning stuff built in.
Okay, I see what is happening there.
Yeah.
Okay.
But it turns out nowadays, both of these are kind of approaching the same thing. TensorFlow is trying to get a little bit more user-friendly. PyTorch is getting a little bit more engineering. So you can't really pick wrong. But I would say if you're just starting, PyTorch is a little easier to understand and get set up.
Yeah. Okay. Well, the one, I don't need anything for vision or that type of recognition. It's more of, I would have like a forecast or some type of predictive situation in it, and then I would have text data layer to tie those together.
I see. So if that's the case, if you're not doing anything like super deep learning intensive, you can do most of it in scikit-learn. And then for like the features that you're building that are specifically more deep learning, like text-based information, if you had images or something, you can do those through here. And then you can always combine the two. So you can use PyTorch and deep learning models to convert the text information into usable information, and then build the actual machine learning model itself in scikit-learn. So you can definitely mix and match.
Yeah, I think that's what it would be. Yeah. Now I'm relatively new, so I'm trying to get my speed up on the things that we're talking about tonight. Getting my pandas.
For sure, yeah. So if you do want to dig into deep learning, I would recommend starting here first. It's going to be difficult without the kind of basic knowledge first.
Yeah.
Before diving into this stuff.
Absolutely. Because I get really confused between languages because I have to code in SAS and R, and I have to add. Like I don't have to do, right?
Yeah. So I think R has APIs for most of these libraries as well, but it's a lot easier in Python because these libraries are written specifically for Python to begin with.
Yeah.
I would suggest making the switch just because it seems like the trend is heading that way, if it's not already there already.
Well, I think so too, for a few reasons. I would like to do other things. So it's going to make it, it's going to make it better for me to extend code if I have to go to devices or something like that.
For sure. Yeah. So if that's the case, I would just start with Python. I mean, commit to Python because it can do everything.
Yeah. Yeah. And then I'll just, in special cases, I'll be calling R. I'm
exactly.
Yeah. Well, thank you, Benny. This is very good. It's very, very much what I needed in the evening. I didn't go to the kitchen or anything like that. You know, I just kept working.
I'm glad you're here.
Yeah. Yes.
I'm glad it was interesting enough to keep your attention for 3 hours.
You know how it is. I appreciate it.
No problem.
Okay.
Thanks,
Right. Talk to you later. Thanks. Bye.
Take care. Jerome wants to know, can you use Python for creating models that will predict a trend based on a specific stock chart pattern? Yeah, for sure. So the easiest way to do that is, so if you come to next class, this one here, I'll mention that. Basically, we're going to do the exact same thing as this, using this information to predict for survived, yes or no. But if we're using kind of stock data or trend data, the features that you're using are going to look a little different, right? It'll be like stock price for the last week or something, average price for the last 5 days or something. That will be the information you feed in. And the thing you're trying to predict for, rather than a survived yes or no, you're trying to predict, you know, is the stock price going to go up or down? Or what is the stock price going to be on this date? So you're kind of forecasting into the future. And so, yeah, it's machine learning is a very broad topic. And so you can use it as an application for lots of different things. And so that's essentially what you're doing as a data scientist on the machine learning side. You're applying those machine learning algorithms to lots of different topics and use cases. Oh, damn, it's 2 a.m. in London. Well, thank you for staying up that late. I feel like a FIFA World Cup or something, people staying up just to learn data science. Cool, any other questions?
Hi, sorry, are you in Canada or in USA or?
Yeah, we're based in Toronto, Canada.
Oh, which is good, great.
Oh, is it? Are you from Toronto as well?
No, Vancouver.
Oh, Vancouver, okay, yeah, we get a lot of students from Vancouver actually, but ever since COVID, we actually had to migrate everything online anyways. And I actually think the online process might even be better than the live process, just because you have the recordings and everything. And so, yeah, we can really teach from anywhere. But if you do want the live experience, yeah, we're based in Toronto.
Yeah, so once a year, we have our budget approval. And then our management will look into how much is the budget, and then like we may have enough budget for some training. So, and it's everything from the management for approval. And now, so true, like Excel is not enough anymore. Like it's, now we need to respond it really fast. And then now SQL, Power BI, automation, Python, like before it's only a small group, ISD is using it. Now they said it's not good enough because they need to make a decision really fast. And not just I ask you and wait for 2, 3, 4 weeks and then you may come, it's too late. And now we want to auto refresh and do it right away. So that now we all have, they are looking at a new approach. It's like automation, computerization. So now this year is very different. We may have enough budget, assign more for computerization, and then we may have more budget for training a computer. But then I work for the government. Everything are very, very confidential and like there's a painful process.
Yeah. So yeah, if anyone else is interested too, we do a lot of corporate training. And so we've done lots of big companies. I don't know, we did Canadian Tire, we did Globe and Mail, we just did BMO recently. I teach a course for Singapore's management university. So yeah, we do have a process for that. So if you are interested, just shoot me an email. I'll send over all the required documents. If you need pricing and stuff, if you want to send that to your boss, we can work through that as well.
Yeah. So if you can give me your record this video, they need to see everything.
Oh, yeah,
Like,
sure.
because it's from us to the director, the manager, director, executive, like it's a long process. But I can tell you once it's set up, like pretty much stable.
Right.
Yeah,
Yeah.
which is
So
like, and and I have to tell you, you are a very nice, wonderful person. You are a good
oh,
tutor.
thank you.
I'm lucky. So I will I sent the link with my team, and more people experience that. It's not only me, but other people like
Yeah,
have
for
the
sure.
feedback, and then if we all support, then it's a long process.
Perfect. Yeah, we can definitely work through that. Just shoot me the email and we'll go from there. Thank you for the kind words. She's not a paid actor for everybody else.
No. Like it is true. Like now, it's unlike the old days. I can go for Excel. Like I can take my time, do a report, wait. And now it's everybody are in survival mode, right? Say
Yeah,
there's a
definitely.
small company now. They are so sad to see, like they have to see how they incorporate outside data to decide if they have to close up or
sure.
what else. So
Yeah, so that is a lot of our corporate training. It's helping companies go from their old tools to this newer version. And because, yeah, you kind of have to do it if you want to be able to compete with other companies that are using data science, right?
yeah, it's not a choice now. It's
Yeah,
even though for government, everything wants to be online, and now they make a decision is real fast. It's like because it's especially say PC housing or welfare, if they do not take online or everything computerization, the lineup outside the office is huge. It's 4 to 6 hours lineup outside of the office.
Yeah.
And then people are PWD, seniors and with disability. So we have management have to make a really fast decision, and the report cannot wait for 3 weeks and it's too late.
For sure. Yeah. Yeah.
Sorry.
I know what it's like. Okay, cool. Thank you, Amy.
Thank you. So yeah, thank you. Please send me all the information because I have to let them review. Like,
yeah, definitely.
Thank you for the courses. This is good.
No,
like for the free courses, like then I can experience that and then I can share with my team.
For sure. Yeah, that's the idea. Cool. Thanks, Amy.
Thank you.
So I probably have time for one more question. Does anyone have anything else before we call it a day? And again, if you do have any more specific questions, you can email me or attend the next workshop and we can continue the discussion from there. Yeah, everybody here good? You guys stuck to it till the end?
Great, thanks.
Awesome. All right, thank you, everyone. I will see you guys next week, hopefully.
Thank you so much.
Thank you.
Thanks, everyone. Take care.
Bye.
Have a good night.
Take care.
Aling gusto. Pero sa ako, dahil hindi, yung pamangan na kasubungan.